All right, so the things we'll talk about today. Quick introduction to home labs. We'll talk about setting your own goals. We'll talk about architecture, creating a core build. We'll go over some exercises. We'll talk about isolation to make sure that you keep things safe. And we'll talk a little bit about scaling and automation once you get past the beginner stage. And then we'll look at some additional resources that you can look at after today. And then I save the fun stuff for last. We'll do a quick lab tour of the silly things I have running in my home lab. Okay, so let's start with an introduction to home labs and how they're different from cyber range. So home lab is for learning, experimentation, testing. It's very informal, and it's basically your personal workshop, your digital workshop. Cyber range is a structured, repeatable environment. It's security specific, and it's kind of like a flight simulator for security teams. It's training under realistic conditions. So you can build a cyber range at home, but if you want to do other things, it's better to do a home lab. So why do home labs matter? It lets you experiment and try new things without getting fired from work. You can detonate malware, you can screw up the network, you can take stuff down accidentally, and it's your fault, and you fix it at home, and you don't have to explain it to anyone. Okay, so let's talk about defining your goals. So first, you're going to want to figure out, like, what's your focus? Like, what do you want to do? What do you do at work that maybe you want to spend some extra time at home? Are you in offensive security? Are you going to want to do exploit development and testing, adversary emulation, post-exploitation and C2 testing? Or are you in the defensive side? Do you want to do detection engineering, threat hunting, forensics, or network monitoring? And if you want to venture a little farther away from security, you could be doing infrastructure and engineering. So automation and configuration management, network design and segmentation, identity access management, DevSecOps and pipeline hardening. Or you can do research. I had a coworker who was actually playing with ZFS the other day. He was trying to figure out if he could inject a malicious file or user into the ZFS backup on his personal system. And personal development, obviously. So all of this is going to contribute to your personal development. Okay, so next you're going to want to look at figuring out what kind of architecture you want. And where are you going to get your hardware from? What sort of virtualization are you going to do? How are you going to design your network? So here are some ideas for hardware sourcing. So in the upper left here, you have whatever's sitting in your closet, right? There's an old laptop or that Raspberry Pi that you're going to use for a project. Dig out the old hardware. As long as it's relatively new, you can get virtualization stuff running on it, no problem. You can also buy. So in the top middle there, we have Newegg. If you're lucky enough to live near a micro center or know somebody that lives near a micro center, you can get great bundle deals on different hardware. Or you can run to eBay, and people will sell you all sorts of hardware. You can assemble it yourself or buy pre-built systems. And so that leads to the one in the upper right there, the Monkey. There's this website called ServerMonkey. Oh, I need to mention too, I'm going to go through a ton of software and resources and stuff like that. You should all be able to grab the slides off of the RSS website at the end of the conference, but at the end of this, I have a QR code and a link to a GitHub gist, which has links to everything. So if you miss anything, you'll be able to get it at the end. And that second slide with my LinkedIn, if I left anything out, please contact me. I'm more than happy to send you links to anything that I may have missed in that list of resources. But ServerMonkey.com, they take and recycle old servers. So if you want some of those super loud Dell R whatevers, they'll sell them to you. Bottom left, family and friends. Maybe they have old systems they don't know what to do with, right? They don't know where the recycling center is. They've had it sitting around. They just haven't thrown it in the trunk and gotten rid of it yet. Offer to take it off their hands. In the bottom middle, your employer. So your IT department rolls over laptops on a pretty regular basis, every 2 or 3 years or whatever. You just go to your IT department and say, hey, do you have a program where you sell old used hardware to your employees? That's another great way to get really nice high-end hardware at a reduced cost. And I haven't done this, but I've heard of some of my friends doing this. If you go directly to the recycling center, sometimes they take a whole bunch of stuff off the street and they have to process it, and sometimes they'll sell it to you dirt cheap. Okay, so hardware requirements. When you're looking at all this stuff, you're going to want to take certain things into account when you're building a home lab. The noise. Is this thing going to live in your office with you, or are you going to want to listen to a jet engine all day long while you're messing around? So you might want to look at some of the low power, low noise, fanless type systems. So like a Raspberry Pi with a heat sink or something like that. Power. So your electric bill is going to go up if you're running a bunch of new hardware. So you may want some of the eco options that are available. And then size. So there's a lot of home lab stuff that I follow on YouTube and other various social media. A lot of them are experimenting with these little mini racks, right? So that you can just pick it up and take it with you, but it's running a Kubernetes cluster and a bunch of different hardware in it. You might want to consider that, especially if you live in an apartment or someplace where you don't have a whole lot of space. So you'll want to take these into account while you're planning. Okay, so next we'll talk about virtualization. So in the event that you don't have a plethora of hardware to work with and you want to use maybe just the bare minimum, you'll want to use virtualization because you can create lots of different machines off of a single device. So the first one here doesn't really count, bare metal. You can do what you want to do by just installing it right on the base OS. So install your Nginx server, run that FTP server or whatever right on the bare metal. But my recommendation is to try out virtualization. So there's a couple different types of virtualization that you can choose. There's a bare metal hypervisor, which is the OS. So you install the hypervisor and it is the operating system and it has all the virtualization stuff built into it. There's also hosted hypervisors. So if you don't want to like wipe your disk and create like a hypervisor server, you can install a hosted hypervisor. So installing something like Parallels if you have a Mac, or Oracle's VirtualBox if you're on Linux, libvirt, and of course there's VMware that you could as well. And that just is an application that runs on your computer that you can then create virtual machines and still use your machine like a desktop. I would recommend the bare metal hypervisor, like create some dedicated stuff to what you want to do. But if you're just bootstrapping, then the hosted hypervisors are a good alternative. So network design. So when you get to network design during your architecture planning, the goal here is to reduce the blast radius, right? So if you're going to be messing around with malware or other dangerous things, you want to make sure that it does not get out. And so there's 3 strategies you can use here. So there's segmentation, VLANs, and isolation. So segmentation is when you use routers, virtual switches, or firewall rules to define distinct zones. And your VLANs are virtual networks so that you can use a single physical switch or interface. And then isolation prevents accidental misconfigurations. So start there if you can. An analogy to this is segmentation organizes your network into rooms. VLANs label the doors between them, and isolation locks the doors when you don't want any traffic passing through. We'll talk a little bit more about this later on as well. Okay, so once you have some idea of your goals and your architecture and your layout, you're going to want to start your core lab build. So this is choose your own adventure, because this is going to have to align with your goals and what you want to get out of this. But I needed some sort of concrete example for you. So today's adventure, we're going to talk about Proxmox and Portainer. So the first thing you want to do is start setting up some of your hosts. So you'll want an attacker host. So I've put the logos for Parrot OS and Kali, which are both pen testing Linux distributions. You want to set up some victims, so misconfigured Linux server, or Windows XP box, or a vulnerable Windows instance. And then you'll want a monitoring host as well, so something like the Security Onion or Waza. Okay, so some VM setup tips. Use snapshots. They're going to save you. So when you screw something up, you can roll it right back to the snapshot. So if you detonate that malware and it's on the box and it's completely taken over, you can roll back your snapshot. Templates are a little trickier. So when you have your hypervisor set up, you can clone a VM. The problem with that is it takes everything. So it has the same MAC address, the same IP address, the same configuration as the original one that you took. And so there are some techniques that you can use to templatize it. And it essentially erases those unique pieces so that when you start it up, it refreshes it and gets new ones. But once you have a template and you have a really good template, you can quickly roll out new VMs from your template. So if you've forgotten to take a snapshot, this is the next thing you'll do, is just create a new box. And then cloud images. So these are lightweight VM images built for rapid deployment. They have built-in Cloud Init support, which, if you're not familiar with Cloud Init, it will set up users, SSH keys, host names, and networking at boot. That's stuff that I was talking about for the template. It's a great starting point. The issue that I've run into with cloud templates is usually it's a bare bones machine, so it will deploy it into my environment, but it has 2 gigs of RAM and like a 100 meg drive on it. So you have to do all the extra work to expand it out to make it what you want it to be. But they are super quick to deploy, and they have sane defaults, and they're ready to go. So if you just need a quick machine up so that you have a command line that you can start installing packages and doing stuff from, cloud images are awesome. Okay, Proxmox. So if you've not heard of Proxmox, it is open source. It is enterprise virtualization. They have support for VMs and containers. It does software-defined networking. You can cluster them. It has high availability. It has Ceph built in so that you can do distributed storage. It's fantastic. I love it. I have it in my home lab. There are other options for hypervisors, which I showed in that previous slide, but this is the one we're going to look at today. So just a quick look at what you see when you log into the Proxmox dashboard. So over on the left-hand side, you have your data center. This is a single node cluster, so PVE is the single node, and then underneath you have your VMs listed, your software-defined networks, and then the storage at the bottom. Down at the bottom you have a log, so when you start and stop VMs, you can see what's going on down there. And there's tons of options. You can see in the middle there's search, summary, notes, cluster. That's where you access all of the configuration of your VMs and networks and user permissions and backups and replication and all of that. And it's great. It runs in your browser. So this is what it looks like when you pull up the console for one of your VMs. Like, it's a command line interface right there in your browser using JavaScript. You can also configure it to use Spice. And there's another one I don't remember because I never use it. But Spice is great. It's almost like using a remote desktop. Okay, so Portainer. We talked about VMs. Portainer is a great web UI interface to your Docker cluster. So it is a paid product, but they have a community edition. It does container management. It has an easy-to-use UI. And I've not used it for most of these things, but it has support for Docker, which I've used, Docker Swarm, Kubernetes I've used, Podman, and Azure, their container product. So this is what Portainer looks like when you log in. So this is a dashboard. It's telling me how many stacks I have. Stack is essentially a Docker Compose file, so it's a set of containers that are running together. It'll tell me how many containers I have running, which is 28. I have 114 images downloaded, 48 volumes, and 13 different networks. So instead of doing all this from the command line, it provides a nice, easy-to-use UI where you can see what's going on in your local Docker instance. And so this is a quick look at what a stack looks like. So in this specific example, it's a bad example. I should have put 2 on here, but this will run a single container. But if it needed a database, you could also put that in here, and it will spin up both containers. So this is how you would create a stack for Kavita, which is a comic book reader, and map your volumes, set your environment variables, and then open up ports. And then this is what the stack looks like within the UI. So you would take this and stick it. There's an editor tab. I don't know if you can see it, but you would drop your configuration, your compose file essentially in there. Then you click the start button, and it just pulls everything down, spins it up, and then you're ready to go. Okay, so next we're going to look at a few different exercises just to give you some ideas of things that you could run in your home lab. So the first exercise we'll look at is offensive security, so we'll do some exploitation. The second exercise we'll look at is reverse engineering some malware. And then the third exercise we'll look at doing some detection work. So, oh, right, I didn't really know where to put this slide, so I kind of threw it in here. This is a project that I absolutely love called Game of Active Directory. And it is a set of scripts to stand up virtual machines and install and configure them with an Active Directory network. And so when you run it, it will provision the VMs, log into them, configure them, link them all together, and you end up with 2 VMs, a forest, a domain, and a workstation, and a bunch of sample users, and they're all named after Game of Thrones characters. And then there is a walkthrough of ways to exploit and examine an Active Directory system. So absolutely phenomenal project. I highly recommend it if you're interested in offensive security and messing around with Active Directory stuff. Okay, so let's move on to the exploitation exercise. Okay, so first we're going to stage our systems, then we're going to run the exploit, and then we're going to escalate privileges. So for these exercises, because I don't trust the demo gods, pre-recorded videos. So we will watch the videos together. I have slowly stepped into all the different things that you'll need to do. So for the first one, you'll see sort of lots of steps, and then in the later exercises, we're going to do less steps because you've already seen them with the first exercise. So the first thing you're going to want to do is upload your ISO. So this is how easy it is to get started. So you're going to grab your ISO. There's a little upload dialog. You're going to send it up to your Proxmox server, and it's going to put it into your storage. And then once you have it, you can reference it from a VM. So we're waiting for a task OK. So it almost says it's still running. There, now it says task OK. That means it's been uploaded. And now we have a new ISO available to us. Okay, so next we're going to create the victim VM. So this is how easy it is to create a VM. You click the Create button in the upper right-hand corner. You give it a name. You're going to pick that ISO image that we just uploaded. This is a Windows image, so we're going to tell it it's Windows so that it adds some extra flags. And then I configure Spice just because I like it better than the JavaScript, but you don't have to do that. You can do it all within the browser. And then I think I set the amount of RAM. I'm going to give it 2 cores. And I'm going to tell it to pass through directly to the CPU on the host instead of emulating a different type of one. And then you have to tell it what network you want it on. And then I checked a box saying I want you to start it as soon as you create it. So there it is, and it's starting up. And so you can see Windows is now booting. Starting Windows. And this is a Windows 7 machine because we're going to exploit Eternal Blue on it because it's super easy. All right, and we have the installer. I think I can skip this. So I skipped over a bunch of the OS install because I don't want to stand here and make you watch progress bars. So the point of this video is just to show you that we boot into a desktop. And yes, so in this video, what we're going to do next is we're going to prepare the victim. And there's really no prep needed. I just wanted to put something meaningful. So I'm going to create a folder on the desktop because nobody stores passwords and text files on their desktop, right? So I'm going to create a text file and I'm going to put a password in it. And then when we exploit it and get a shell on the machine, we're going to show you that same file, essentially, to prove that it worked. I'm sorry if this is hard to see. Okay, so the password is I love home labs. Okay, so we got a folder on the desktop. We have a passwords file. We put a password in it. So our victim is now ready to go. So now we're going to prepare the attacker. So I've already uploaded, so this is the part I was talking about where I'm skipping steps. I uploaded the Kali ISO, and I ran the installer, and I created a VM, and I set up the OS. And so now we're just booting directly into Kali. This one might be easier to see because I made the font of the console bigger. Okay, so now that we have everything set up, we have our victim and we have our attacker, we can run the exploit. So I have my victim. And I'm pulling up the command line to find the IP address. So it's a 192.168 address. Now I'm going to pull up the attacker VM. And when we can see them side by side now. All right, so I'll open a terminal and start up Metasploit. Oh, I was going to do network scan first. So the first thing I'll do is I'll scan the victim to look for open ports. And you can see that the typical Windows file sharing ports are open. And so I'll start Metasploit. It's written in Ruby, so it's slow. All right, so I searched the list of exploits for Eternal Blue, and number 10 is the one we're looking for. So I'm going to type use 10, and that will load the exploit. And then I'll ask it what are the options that I need to pass it. And here I'm going to set the payload to make sure that it's Windows 64-bit. And the payload it's going to send as a reverse TCP shell. So I set the remote hosts option to the IP address of the victim, and I run the exploit, and it's doing its thing now. And it was successful, sent the second stage, and now we have a interpreter prompt, and if I type shell, it drops me right into a shell. So now that I'm on the system, I can go to the users directory, there's an owner user, and I'm going to go onto their desktop, and there's the folder that we created earlier, and inside is the passwords folder, or the passwords text file, and it has the password inside of it. So we've successfully exploited a Windows 7 machine with the Eternal Blue exploit. Okay, the next exercise we'll talk about is reverse engineering. So the steps we're going to go through here is obtaining a sample, disassembling it, and then analyzing it. I'm not a reverse engineer, so for those of you that are, I'm sorry, this is extremely rudimentary because I didn't really know what I was doing. But that's why we home lab, right? All right, so the first thing you want to do is obtain a sample. They're everywhere. There's some in GitHub. VX Underground has a whole bunch as well. We skipped a bunch of steps here. What I'm running right now is Flare VM, which is a Windows malware analysis distribution from Mandiant. So it has all of the reverse engineering tools that you'll want to use already built in. So very easy to set up. What I'm doing here is I'm grabbing a RAT, or a remote access Trojan. So the archive password is infected. So all of the zip files in this collection are password protected, so you don't accidentally detonate them if you have no idea what you're doing. And so you have to look for that password on there. But once you get it, you extract it. It's going to ask for the password. So we type in infected. And now we have both the client and the server for the RAT. So next we're going to disassemble it. So the tool I chose is the one that I'm familiar with, which is Ghidra. You may like IDA, or there's a couple others. Ghidra is the one from the NSA. So take that advice with as you will. So it's a disassembler. So I'm just going to kind of quickly walk through the steps of what you do. So once you have your sample, you're going to create a new project in Ghidra and name it. You're going to give it the path to the executable that you want to analyze. I don't know Ghidra well enough to understand why there's so many steps, but like once you get it imported and you click the Analyze button, it will pull it up in a disassembler for you, which we'll see here shortly. Okay, so it's doing the analysis of the binary. And there's its report, and I'll click OK. And then you click the dragon. And it will disassemble it. Oh yeah, this is the part I got confused. For some reason, it doesn't just auto-load it. You have to open it within the disassembler. So here I'm going to do open. I'm going to choose the binary and click OK. And there's the disassembly. Here's some more options you can give it when it's doing its analysis. But you end up with a whole bunch of assembly, which I'm not good at reading. So you can tell it to sort of convert it into C so it's a little more readable, and that's what's over on the right-hand side. I'm so sorry, it's really hard to read this. But the great thing about Ghidra is, so the next step is doing the analysis. You can double-click on the functions, and it will navigate through the code for you. So if you're good at reading C code like I am, that makes it much easier than trying to traverse your way through the assembly. You can double-click. It's just like using an IDE. You can sort of walk through the code. It allows you to comment on it, so you can write your own notes about what you've discovered or what you think it's doing. And it's a great way to learn. That reminds me. There's a great resource which is not in the resources at the end of this, but I can't remember the name of it. It's like Cracked or something like that. They have a whole set of binaries that you can download and disassemble at various levels of difficulty. So if this is something you're interested in, this is a great way to learn those tools and techniques. Okay, our third exercise is detection. So just like the exploit, very similar to the exploit, we're going to stage the victim. We're going to exploit it from the attack host, and then we're going to review the monitoring system to see if it caught it. I'm also not a blue teamer, so I was terrible at this as well. I finally got Waza set up. And so Waza is pretty cool. It's like the Security Onion. From what I understand, Security Onion is more network-based, or Waza uses an agent. But I've found that a lot of these vendors that do these things start to cross over and do what the other one's not doing. So maybe the Security Onion's using agent-based stuff as well now. Within Waza, it has a section for agents where it tells you how to install the agent. So I clicked Windows, I gave it the IP address, I think that's a host name, and then it gives you a little snippet of PowerShell. And so here I'm going onto my Windows machine, I'm going to run that snippet of PowerShell, and what it'll do is install the agent. And so if you're not familiar with what any of this is, the agent is a background service that watches the logs and things on the box and then ships it to a centralized location for your threat hunters and blue teamers to analyze. So, I think I left this in here. Don't make the same mistake I did. Run it as administrator. Because it won't install that agent otherwise. I think that's all I had in this video. All right, so next you're going to want to generate some events. So back on the machine that you just created, the machine with the agent. You're going to want to do something that an attacker would do. And so I struggled a little bit to try and figure out what things Waza would alert on by default. And one of the simplest things you can do is create an administrator user, right? Because that's typically what an attacker will do, is give themselves an administrator account that they control, that they can then do nasty stuff. So I know it's terribly hard to see, but what I've done is I've created a user and added them to the administrator group. So now I want to review the events. So within Waza, you can then pull up the logs that the agent shipped to it, and you can start looking for evidence that an administrator was created. And that is what I'm trying to show you in super small text. That a new user was created and they were added to the administrator group. And so now you can write alerts and stuff around this, but that is outside the scope of my expertise and this demo. You can start writing things that are, write alerts on things that are interesting to you. Okay, so more exercise ideas for you. You could install local LLM. Set up a local ChatGPT and practice AI offensive techniques. Do some prompt injection. See if you can poison the model, create your own model and see if you can poison it. Single sign-on. This is something I haven't done yet, but you could create an Active Directory server and try and implement single sign-on within all the different applications and stuff that are on your network. Set up a VPN so you can access your home lab from anywhere. WireGuard is super popular, but you could try OpenVPN or IPsec or any of the other exciting ones. Certificate management. You can try and set up certificate management. I've taken the easy route. I use Let's Encrypt, and I have Traffic. My proxy server handles all the certificates on my network. And then if you're feeling very brave, you could create a Kubernetes cluster and try and get that working. And if you got Portainer running, then you can put your Kubernetes cluster right in Portainer and manage it that way as well. Okay, so I told you we'd talk a little bit more about this later on. So isolation. So while you're running exploits or messing with malware and stuff, you want to make sure that you keep the parts of your network safe that you don't want getting wormed or infected or ransomed. And so there's a couple different strategies to do this. You could use physical separation. If you have the extra hardware to build an entirely separate network, do it. You can't accidentally misconfigure it if it's not connected to your regular home network, right? You can also use firewalls, so you can set up rules. Snapshots are your savior. They will pull you back out of a giant mess. So the hardest thing about snapshots is remembering to take them. And then software-defined networks. So you can create, I know specifically within Proxmox, you can create your own software-defined network. And then if you have like a cluster of machines, and I'll talk about this in a minute because it's how I have it set up on my network, you can isolate a group of machines onto their own little software-defined network. Scaling and automation. So we made it all the way through the beginner stuff. Now we're going to get a little more advanced by automating pieces of our home lab or maybe scaling them out. So the first thing you're going to want to look at is provisioning. So provisioning is creating a resource or like a VM. And so there's a bunch of different tools to do this. So there's Pulumi, which I've never heard, or I've heard of it, I've never used it, and it's a direct competitor to Terraform. So then we have Terraform, which most people have heard of, and then they made some licensing issues with the community, and OpenTofu was created. So OpenTofu is basically the same thing as Terraform. And then you have Packer and Vagrant. So I'll show you an example of Terraform in a minute, but actually, yeah, I should probably explain that. So these tools allow you to script out what you want as far as like a physical machine goes. And so Terraform, you'll use providers to create those assets. Packer and Vagrant are a little weird. Vagrant is remember way back at the beginning we talked about hypervisors. So Vagrant works with like VirtualBox, and it's a script, and you tell it what you want, and then it will go to VirtualBox and then stand the thing up for you. Packer is a great way to make templates. So it will create VM images based on a script. So instead of walking your way through the ISO install of your operating system, you can have Packer do that for you and spit out a VM image on the end. So you can have it scripted to create those images for you so that you can import them into Proxmox and use them as templates. Sorry, I'm getting a little technical on some of this stuff. But so I just wanted to show a quick view of what a Terraform script looks like. So I know it's kind of hard to see, but at the top, you define your providers. So in this example, we're telling it we want to use Proxmox, and then in the provider section, we give it all the information about Proxmox. So we give it the URL, the token, the secret, and you have to set that up in Proxmox so that it can connect in. And then you have the resource. So then you tell it, I want you to create me a VM, and I want you to call it Terraform Demo. I want you to give it 2 cores, 2 gigs of RAM, a disk, a 20 gig disk, and I want you to put it on this storage within Proxmox, and I want you to put it on this network. And then at the bottom of that, you can tell it, I want a DHCP, the IP DHCP, and I want to put this SSH key on it. And so then when you run Terraform, it will connect to your Proxmox box, and it will provision a VM, and it will configure it the way that you have it laid out in the file, and then it will spin it up, and you'll be ready to go. So it's very repeatable, right? Okay, so once you have your asset provisioned, you're going to want to automate the configuration of it. So there's lots of different tools for doing this part of it, the configuration management. So we have Ansible, Chef, Puppet, and SaltStack. I'm sure there are others, but these are the most popular ones. The one that I use is Ansible, and it, oh yeah, I gave an example of this one too. So this is what an Ansible script looks like. So we have our VM, it's up and running, and it's a bare bones system, right? we're going to want to configure it, install certain packages. Maybe you want it to be a web server. That's what Ansible is for. So in this specific case, or this example, we've laid out tasks for the Ansible script to do. We want it to make sure the system packages are up to date, basic utilities are installed. We want vim, curl, get, and htop. Create a new user, add an authorized SSH key, ensure the firewall is installed, and then configure the firewall so that port 22 is open so we can SSH to it, and then turn it on. And so Ansible will SSH into the system, and it will apply all of these things. What it does is it checks the system first, and if it isn't configured the way that it's supposed to in the script, it will turn that on. And so it's a good way to make sure that your system stays consistent as well, because it will consistently keep applying the settings that you have in your script. Extra resources. So these resources aren't specifically devoted to security. These are like home lab guides, but they do cover security topics. So they talk about setting up VPNs and configuring secure systems and stuff like that. But they're fantastic resources for getting stuff up and running and learning more about different technologies in this space. Okay, fun stuff. So I'm going to tell you about the security stuff in my lab first, and then I'll talk to you about the fun stuff. And then at the end, we'll have questions, and you can even come up and tell me what you got running in your home lab. All right, so the security stuff I have running in my home lab. I have the Game of Active Directory thing that I talked about earlier. I also have I was working as a pen tester, red teamer, security analyst for a small security startup, and one of the tasks that I had was to test our managed detection and response company. And so I set up a small software-defined network within my Proxmox instance. I fired up a pfSense firewall server, a Kali Linux box, and a Cuckoo sandbox. And really, Kali and pfSense were the two things that I used. But I configured pfSense to route all of the outgoing traffic from that tiny software-defined network through a VPN. So all of the work that I did on Kali and testing this managed detection and response provider, it looked like all my traffic was coming from Croatia. And so I was able to run tools, and everything filtered out through this gateway that went straight out into a VPN and then came out on the other side of the world. The Cuckoo Sandbox was for testing custom malware development. So you can take files and basically detonate them inside of a sandbox, and it will record all of the interaction that file has with the file system and the network and everything else that's going on, and it will generate a report for you. So I use it to test files that I think are sketchy or maybe malicious, and I want to make sure that I'm not going to do anything nasty. And then I have a Windows Dev box, which I use for antivirus evasion techniques. So one of the certifications I was studying for is the OSEP, and they teach a lot of antivirus evasion techniques for Windows. And so I was using the Windows Dev box for that. So anyways, those are some of the things that I have set up in my home network to help me with offensive security related stuff. Okay, so this is pretty much the end of the presentation. I'm just going to sort of run through the things that I'm also running in my home lab that are not security related but are more fun. So first up is homepage. This is just a dashboard. It's built off static files, and you can see it's links to all the different services that are running in my lab. pfSense, so my firewall and gateway is pfSense. That's what's plugged directly into the internet. And I actually have a telegraph running on it, which feeds all of the connection information into a Grafana dashboard so that I can complain to Spectrum when my shit is down. It maps it out, tells me when it was out, how long it was out for. it's very, very useful in getting a couple bucks knocked off your bill. TrueNAS. So I have a NAS. I use TrueNAS. I have a bunch of pools of drives. I have, we'll get to that. I have a bunch of containers running on a Portainer system, and they all use NFS shares for their storage. So everything goes and gets stored in TrueNAS. So the containers can go up and down. It doesn't matter. They will just connect back in, and that's where they store all their data. And then I have backups running on that data. I have my own private GitLab instance, so I can store phishing lures and malware and other nasty offensive stuff that I'm working on and not worry about getting DMZ takedown or freaking out the security teams at GitHub or GitLab. Grafana dashboard, I already mentioned. N8N, this one is all the rage right now within the home lab community. It is basically a replacement for Zapier, if you've ever used Zapier. You can hook it up to do automation on all sorts of different APIs and things. I've mostly been playing with its AI-related stuff. So I set up a Signal client REST server, and I use N8N and that to send me Signal messages on stuff that's going on my network. Plex. Anybody who has a home lab is going to tell you that they're running Plex. It has my old DVD and Blu-ray collection, and I can stream it, and I put the kids' movies on it and everything. It's great. They're a little sketchy with their privacy, and they've gone a little to the wayside. And so I also have this, which is Jellyfin, which is an open source project, which essentially does the same thing, but it is not mature, not as mature as Plex yet. Earthsats TV, if you've ever used like Pluto TV, this is like one of those sort of channel guide type things. So it's like real TV where it just continues streaming a series of things. You can insert your own playlists. You can create commercials. You can have your own Netflix logo come up. It's just sort of a neat thing to do streaming. Kavita, I mentioned earlier with that compose file. This is for comic book reading. Image is a Google Photos replacement. Paperless NGX is a way to store all of your documents. So if you have this, get a scanner and you never have to store papers again. It's fantastic. It supports tagging, it supports workflows. So as soon as you bring in a PDF, it will convert it to text and look for specific like keywords and numbers, and then it will automatically tag it and put the right correspondent on it and archive it for you. Monica is a personal relationship manager. So if you are like me and you can't remember your friends' children's birthdays and things like that, this is what that's for. You can put all that stuff in there. It will email you reminders. You can document the last time you talked to them and what you talked about. It's sort of like it's a sales tool, right? When you have customers and you want to have a personal relationship with them, but you have so many you can't remember. This is for personal use, so that you can do the same type of thing and really show the people that you care about that you're interested in what they're doing and you've actually put the time into documenting it. Home Assistant. Everybody loves Home Assistant. It's super flexible. If you have any IoT devices in your house, they're going to be most likely supported by Home Assistant, so you can create your own dashboards. I don't know how many of you have wives that want that stupid skylight calendar like mine. I created a Home Assistant dashboard for her instead because it's much more flexible and it doesn't cost $700. Mealy, we put all the family recipes in here. It's a giant cookbook. You could share it with your family and friends. My mother-in-law uses this quite a bit. She wants to know, oh, can I have the recipe for that? Sure, here's the link. Vikunja is, there's 1,000 of these. This is just the one that I picked. It's a task manager, and it's pretty good. ChangeDetection.io, if you want, this dovetails nicely with the hardware stuff that we talked about earlier. If you could set up change detection to watch restocking and price drops on hardware that you want to buy. I use it to watch for like new comic book series. I have it watching for firmware updates. It basically monitors the website and it will let you know when things change and it will email you right away. It's very useful. And then Link Warden, This is like a bookmarking site, but it will also reach out to the website and fetch the contents. So you'll have your own like archive.org version of it locally, so that if the link goes away, you can still read it. And then Sterling PDF, this thing, anything you ever wanted to do to a PDF, this thing will do for you. It will strip signatures. It will convert to image or HTML. It's fantastic if you have that PDF that will not do what you want it to do. All right, so here's the QR code and the gist to all the resources from today. This should also be in the slides that are on the RSS website. Thank you guys. I hope you learned something today. And then we can do questions, or you can tell me what you're running in your home lab, or whatever you want to talk about. Yeah?
I'm wondering, when you disassembled the code and got the assembly back, have you ever fed that assembly to an LLM to analyze?
That's a great question. All right, so I think this is, I recorded one last year, and I couldn't hear the questions because it wasn't in the mic, so I'm going to repeat your question. He asked, have you ever fed the disassembled C code into an LLM to see if it can help you? So I did a Try Hack Me holiday challenge, and they had a malware that was installed on a box. So I downloaded it and got a sample of it, and I was trying to figure out what it did. And so what I did was exactly what you mentioned. I fed it into Ghidra, disassembled it, gave the disassembly, I packaged it all up and gave it to an LLM, and I said, what is this? What does it do? And it identified it as malware, and that one of the things was I was trying to get like the encryption key or something, and I could not, from the disassembly, figure out what encryption libraries it was pulling in, and the LLM was like, oh, no. It brought its own encryption with it. All of the code is in there. So I was like, oh, no way. So this malware had AES custom implemented inside of it. It never referenced any of these. I never would have figured that out without the LLM. So yes, 100%. It's definitely useful. Yeah. What else? Yeah.
You think you're talking about snapshots and things like that.
Yeah.
What about like full backups? Like, do you recommend doing any sort of like full backups, or like how would you approach that from a full backup standpoint?
That's a great question. This is something I've been looking into too. Okay, so the question was, snapshots are great, but what about full backups, and would you recommend doing full backups? I'm struggling with this too, and I've even talked to LLMs about it, and I get like waffling responses. I'm going to give you the senior developer response. It depends, right? It really depends on what your goal is, and so I think the way that you break it down is like if you know that you're always going to restore to the same hardware, you do a full disk backup, right? So like bit for bit, just clone the disk. If you want something more flexible, if you want to be able to transfer it to another machine, then you have to pick specific configuration pieces from the machine and only back that stuff up. That way there's a little extra step. You have to stand up the machine first, and then you restore the configuration to it. The problem with that is it's a little more painful because now you need to figure out, based on the software that's running on that you want to back up, you need to know what the important pieces are, right? So I was actually looking at this the other night with pfSense. Like, I want to back up pfSense, and it has something built in, and it will pull down the config XML file, but it won't reinstall the packages for you. So you have your config, but then you have to go reinstall the packages. So like, it's not an easy answer. Yeah.
An aspirational home lab person, all of the different things you're running at home, how much hardware are you looking at?
I have a server that I built before my first child was born, he's 10 now, and it's still running. So like, literally, you can dumpster dive, and as long as it's somewhat modern and it can virtualize, you're fine. And plus, like, unless you're like my crazy friend who invites all his friends onto his Plex server, like, you're not going to use all of the resources. Yeah. And even if you have like a dozen services running and it's just you and maybe a couple other people in the house, like, it's not going to cause that much churn because you're only going to be using one at a time. Yeah. Sorry, what was the last part? How concerned about?
How concerned do you think you should be about VM escape, like the?
Oh, a VM breakout?
Yes.
Yeah, so I thought about this. Sorry, the question was, if you're going to be detonating malware, how worried are you about VM breakouts? Know what malware you're running. Like, not all of them have VM breakout code built into it. So just, if you're going to experiment with something, just take a look at it beforehand to make sure it's not going to do that. And if you're really paranoid about it, like I would be, create a completely separate physical network to do it on. Yeah. Yeah.
Is there an advantage to using Portainer instead of just doing the containers in Cosmos?
Oh, that's a great question, too. Okay, the question was, is there an advantage to doing the containers in Portainer instead of just in Proxmox? So the difference is Proxmox uses LXC, and Portainer is built on top of Docker. So if you don't know the difference between LXC and Docker, LXC is almost like a VM. So you'll get a command line, and it's like you're inside of a VM system, whereas Docker, the entry point is the application, right? And the application is running. There's no command line. Like you can exec a command line into the container, but they're separate. That's the best way I can describe it. But like I use LXCs for proxies. So I have a software-defined network and a couple of VMs in it, and no one on the network can get to them. They have to go through the LXC, which is set up as a proxy. And so that was the only use case that I came up with for using LXCs. Yeah. All right. There's 1 minute left, I think. 1 minute? Yeah. Okay. Anything else? Awesome. Thank you guys very much.